Hi, this is Shannon Seaver. Today we are looking at Part B of Section 3.6, Arguments and Truth Tables. We're going to recognize and use forms of valid and invalid arguments so that we don't even have to do a truth table to figure out if something is valid or not. So the first thing I want you to do is to take some time to write all these different items down. We have direct reasoning, and below direct reasoning we have this area right here, and I want you to write all this down, this whole table, in your notes. So pause the video right now and do that. So hopefully you've written down all these things. You will need them, you're going to need to refer to them later when we're doing the work. So the first one I have is to determine whether each argument is valid or invalid and identify any sound arguments. So here is an example. Excuse me. There is no need for surgery. I know this because if there is a tumor, then there's no need for surgery, but there is no tumor. So the first thing we have to do is to separate out our premises and our conclusions. And we did that here below. We wrote, if there's a tumor, then there is a need for surgery. So that would be P then Q. There is no tumor. So this is where they're saying that there is no tumor. So it would be not P. Therefore, there is no need for surgery. And that's how we get therefore not Q. So this one was a little tricky to actually put in symbolic form, but here it is. But now that we have it in symbolic form, we can actually go back and refer to our chart and see if there's anything in this format here. P then Q, not P, therefore not Q. So let's go back to our chart and see if we have that. So, excuse me. We have not P, then not Q. We're looking for P, then Q, and here it is, right here. This one. So that one is already, we don't have to go through the whole format of actually looking in the table or making a truth table, because we know that that doesn't work. It's called the fallacy of the inverse. So when we go back to this problem, we can say invalid based on the fallacy of the inverse. All right, so it's a lot simpler. So if you have those 8 things to refer to when you're actually doing these, you'll know that you don't even have to make a truth table for those. Now let's try this one. The emergence of democracy is a cause for hope, or environmental problems will overshadow any promise of the bright future. So that is our first premise. We have P or Q. Now, because environmental problems will overshadow any promise of a bright future, and I think it's supposed to say it follows that the emergence of democracy is not a cause for hope. So environmental problems will overshadow any promise of a bright future is the next the next premise. So that's Q, because it's the second statement in our first premise. And then it follows, it should say it, that the emergence of democracy is not a cause for hope. That's the conclusion. So here we have it, and it should be not P here. There's a little typo there. Sorry about that. So we need to look in our truth table, our reference table, to see if this is actually a valid argument or not. So we have P or Q, Q, therefore not P. So let's look for that. Notice that the only ones that have the or signs are right here. And these are a not P, not Q. So that would have worked for a valid argument. But we are looking at, in this case, a positive Q and a not P. So the one that matches that is this one right here. So that is misuse of disjunctive reasoning. So it is an invalid argument based on that. So that's what we would write down in our answers. Misuse of disjunctive reasoning. So it is not valid. It's a fallacy. Okay? Now let's look at the next example. If the evidence of the defendant's DNA is found at the crime scene, we can connect him with the crime. So we have P then Q here for the first premise. If we can connect him with the crime, we can have him stand trial. So that would be Q then R. Therefore, if the defendant's DNA is found at the crime scene, we can have him stand trial. So we have our therefore P then R. So let's check to see on our table if this is a valid argument or not. So here, if you notice, these ones are the only ones with all if-then statements. So we have a P then Q, Q then R, then P then R. So this is actually the one that we want, and it does work. It is a valid argument. So this is valid. And why is it valid? It's based on transitive reasoning. Okay, so I want to look at this one because sometimes we have to determine whether or not we're going to have to make a truth table or not. And this particular one, we have people are good, laws are not needed to prevent wrongdoing. So we have P, then not Q. If people are not good, not P, then laws will not succeed in prevent wrongdoing. That would be not R. Therefore, laws are not needed to prevent wrongdoing, or laws will not succeed in preventing wrongdoing. So we have this statement, and I wanted to check on my truth table if there's anything like that. And notice that there really isn't, because we don't have anything that ends in an for a conclusion with an or statement. So because of that, we're going to actually have to make the truth table for this. So remember, we have premise 1, which is this one, premise 2, which is this one right here, and we have an and in between it to set it up. Then the conclusion right here. So this is our conditional statement that we have to make a truth table to solve for. And I've done that on the next screen. So, but before I switch to the next screen, maybe you should practice and see if if this turned out, so that you can check your work and see if that you are doing this correctly. So I would pause the video now and then turn it back on and go to and let it play to the next screen. So here's the truth table here, and there's a lot of columns involved in this because there's so much going on. But hopefully this is what you got. Take a few minutes to look at it, and you'll notice that it ends up in a tautology. So this argument is indeed a valid argument. Now for the last example, I want you to draw a valid conclusion based on the following. We have P then Q. If all people have the same idea of what is humorous, then no jokes bomb. Then we have some jokes bomb, not Q. And then what would it be a valid conclusion? Well, if we go to our table and look at this, we can figure out what it would be. So we have P then Q, then not Q. So we want to look at the top row, because these are all valid. And being that we have this particular thing to start with, we know we needed therefore not P to make it a valid argument. So back here, I would put in here not P. So if I need to put this in English, then I would say the negative of all people have the same idea of what is humorous. Well, what is the negative of all? Some. Some people do not have or don't have the same idea of what is humorous. So that is that one. So remember, for these, you're going to actually refer to the table to find your logical outcome. and then write it in English after that. So that is it for this video for today. If you have any questions, make sure you bring them to class.